Here we are, it is old math again, still talking about the tangent. The tangent is a cool function, okay? It is the slope of the radii of the unit circle. Let me, still got probably another video to make about the tangent as well. So, let's talk about something here. Still talking about the graph of the tangent. We graphed in the last video, and we're going to do a little bit more with the graph in this video. There's one thing I want to talk about here. Let's say we have some angle here. Let's call it theta. Alright? And we know that that point there is cosine theta. Cosine theta, sine theta. Okay? So if I wanted to find the equation of this line here, I know it passes through the point 0, 0. So we're looking at y equals mx plus b. Y equals mx plus b. Well, what is the slope? Well, the slope is going to be rise over run. And clearly that is, if we look at cosine theta, sine theta, and 0, 0, the slope is sine theta over cosine theta. So y equals sine theta over cosine theta times x, and plus b, our y-intercept, is 0. So it's just sine theta over cosine theta times x. And so we get that y equals the slope tangent theta times x. Okay? And now, what's interesting about this is that if we let x equal 1, so let x equal 1, then we get y equals tangent theta. Well, what that means here is that when x equals 1, right there, the y value is, so 1 tangent theta. So interestingly enough, let me do these in a different color. So there's my point 1, there's the output 1 tangent theta. That is when x equals 1, y equals tangent theta, if this is my line. So what that tells me is that this distance here is actually equal, that actual distance, so where that line meets there, that actual distance is the slope of that line. I think that's pretty fascinating. So this actual distance here is the slope of this line. And it wouldn't matter, no matter what circle I draw, let's see if I can draw it a little bit. I can't draw it too big because I won't be able to reach. Let's say we do this line here. So that's theta. All I do is extend this line out to where it intersects with the vertical line straight up from 1. And so that actual distance there is the value of the slope of this line. Now, that's not simple. It'll take you a while to actually work through this and work through it a couple times. Maybe try to find some other resources on it to actually believe this, but it works out here. There's no denying it. Okay? So that leads me to what I was really wanting to do in this video, and that is play with Mathematica again and look at this Mathematica demonstration from Wolfram Alpha, and that shows the let me turn my computer around. How are we looking on time? Is anybody keeping up? 4:41. Oh, we're doing great. So we see that. So this is going to be the graph of the tangent. Okay. So we see there at 0 that the slope of that line is 0. And as we start to go around the circle, we see that the slope is getting bigger, and it actually matches up with this line here from 1 to where it intersects the actual slope is the length of that line. Or you can just think of it as clearly look at the slope of this line here, and as we go closer to pi over 2, we see that it's blowing up to infinity. It's getting bigger and bigger and bigger. Okay? And then we jump over that line, and we see we got that vertical asymptote there. We jump over that line, pi over 2, and we see that we have very big negative slopes. And so that's why this thing is going down in the negative direction. We have very big negative slopes there. As we go, we're getting closer and closer and closer. Our slopes are starting to approach 0. So it's getting closer to 0. And now right there we have the horizontal line that has a slope of 0. And then as we go on around, we see the slope gets bigger and it's starting to get bigger and bigger and bigger in the positive direction. And then as we get to so that's going to be the second time. So 5 pi over, what is that? 3 pi over 2? Where are we at here? Oh, okay, yeah, so we're down here, really looking at it. So the slopes are getting bigger and bigger and bigger. And at 3 pi over 2, we have very big slopes. At 3 pi over 2, we're undefined, so we skip over the line. And then we have very big negative slopes again. And we see here as we approach 0, we're getting a slope of 0 right there. Okay? So let's go through it one more time. This is difficult to get, I believe. But once you get it, you'll find that it's not that hard. But it's hard to really take that step. Okay? So our slope is getting bigger and bigger and bigger. And if you watched in the first few minutes of the video, you'll see that this length here actually gives the actual slope value. And so we can model it like this. But just think of this slope, and if you look at it, it's clearly getting big. Getting really big as we approach pi over 2. It gets as big as we want it to get, actually. And then as we jump, so we're undefined at pi over 2. When we jump over pi over 2, we have really, really big negative slopes. And then they're going to get closer and closer to 0 as we move toward pi. Then as we move toward 3 pi over 2, we're going to get really big slopes in the positive direction. Okay? And then we're going to see that as we hit 3 pi over 2, we're undefined because we have a vertical line again. So we jump over it, we have really big negative slopes there. Okay? And then it's going to start rising, getting closer, closer to 0. And at 0, and if I could keep going around, it would just keep continuing this pattern. Okay, I hope that helps you out with the graph of the tangent function. We'll work a couple problems in the next video, and that should do it for the tangent function. See you in the next video.